In this problem, we're asked to find all solutions to the equation 2 sine of 3 theta plus square root of 2 equals 0. The first thing we should do is isolate the trig function, isolate the sine of 3 theta. To do that, we need to subtract the radical 2 from both sides. So we get 2 sine of 3 theta equals negative radical 2, and then divide both sides by 2. So sine of the angle 3 theta equals negative radical 2 divided by 2. Now we're going to try to figure out for which angles the sine is equal to radical 2 over 2. So you can either think of the graph of the sine or think of a unit circle. So if you have a circle centered at the origin with radius 1, the sine of an angle corresponds to the y-coordinate. So it's asking which angles has a y-coordinate of negative radical 2 over 2. So right down here. So this is negative radical 2 over 2. We can see that there's two angles that would have this y-coordinate, this angle and this angle. So this angle right there. And realizing that because this is radical 2 over 2, that must mean that this is a 45-degree angle right here. So pi over 4 is this little small angle there, which means that one of the solutions will be pi plus pi over 4. So 5 pi over 4. Another one of the angles will be the one all the way around in quadrant number 4, which will be 7 pi over 4. Now, because we're looking for all solutions to this problem, we need to include the fact that not only will the sine of 5 pi over 4 be negative radical 2 over 2, but so will 5 pi over 4 plus any multiple of 2 pi. Because the sine function is periodic with the period of 2 pi, anytime we add a multiple of 2 pi to our angle, that doesn't change the value of the sine. So we need to include that in our solution. So and then we also need to say this is for any integer value of n. Now we have two equations we can solve by dividing by 3. So we get theta is equal to 5 pi over 4 divided by 3, so 5 pi over 12, plus 2 pi over 3n, and then we also have solutions that look like 7 pi over 12 plus 2 pi over 3 times n. So both these are solutions to this equation.